everyone, in this issue I'm going to share with you how to build a multi-brain areas coordinated decision-making spiking neural network using our brain-inspired cognitive engine, BrainCog. Brain-inspired decision-making spiking neural network takes inspiration from the mammalian brain's decision-making neural circuit to build a multi-brain areas coordinated spiking neural network. We first summarize the brain regions involved in decision-making of the mammalian brain and the connections between brain areas discovered by brain science and neuroscience research. This circuit starts from the prefrontal cortex to the basal ganglia, then to the thalamus, and finally to the motor cortex. The orange area is the connection of the inner nuclei of the basal ganglia. Such decision-making circuit contains 3 pathways from the prefrontal cortex to the basal ganglia: the direct pathway, the indirect pathway, and the superdirect pathway, respectively. The learning mechanism is that dopaminergic neurons in the VTA modulate the direct and indirect pathways in opposite ways, which in turn help amplify the differences between the 2 competing pathways and enable rapid decision-making. We used a spiking neural network to construct the excitatory-inhibitory connections between multiple brain regions on the decision-making neural circuit and draw on the dopamine-modulated direct and indirect pathways to optimize the network's weights. In this way, our BDMSN module can be biologically plausible from both structural and mechanistic perspectives. We implemented this model using the basic commands in BrainCog. First, we use node, learning rule, and connections under the base directory to construct the basal ganglia brain area. Based on the interactive connections between different nuclei in the basal ganglia, we defined the connection matrix between different subbrain regions, assigned neural models to different subbrain regions, and assigned the learning rules to the connections between subbrain regions to realize the construction of the basal ganglia spiking neural network. With the basal ganglia as the core, we further construct a prefrontal cortex, basal ganglia, thalamus, motor cortex circuit to realize a complete decision-making spiking neural network from the experimental states to behavior choices, and finally to the execution of actions. In the BDMSN under the Model Zoo directory, we can see the interactive connections between the basal ganglia and several other brain regions are modeled in the similar way to that of the multiple nuclei within the basal ganglion brain area. In BDMSN, the forward function is used to select behaviors based on experimental input states, and update weight function updates the weights based on feedback from the environment. Finally, we take the Flappy Bird game as an example to verify the effectiveness of the BDMSN model implemented by BrainCog. Under the examples decision-making BDMSN from the BDMSN.py, we can see it contains some implementations of the game scenes in which choose-act function is implemented by calling the BDMSN model and to implement the selection behavior based on the input and save the STDP-based traces for the later reward-modulated plasticity learning. And the update net function is used to update the weights of the BDMSN model based on the reward modulated STDP and the offset effect on the direct and indirect pathways after the reward is obtained. The experimental results are shown in this video. And now I will demonstrate the results of the BDMSN implemented by BrainCog to complete the Flappy Bird game. We can see that the birds can start from zero in the process of interacting with the environment to learn the correct strategy to pass the pillar and keep a stable and safe flight. In addition, we compared the experimental results of leaf neuron and simplified HH neuron learning process and find that it can learn well for different neural types. Our model also has the ability to support decision-making for real UAV scenarios, such as UAV flying through doors, windows, and obstacle avoidance. If you are interested in our work, you can also to set the following 2 articles, and you are also welcome to contact us by email. So that's it for today's introduction to the multi-brain coordinated, brain-inspired decision-making spiking neural network implemented by BrainCog. Thank you very much.